Let's discuss extrema and extreme value theorem. First, we need to define extrema. Suppose I have a function f defined on an interval I, and that interval contains a point c. Then my functional value, f of c, is a minimum if it is less than or equal to all of the other functional values on the interval. While if I have my function, my point c, and my function evaluated at c is greater than or equal to all other values of x, f of x, this is a maximum. And we call these extrema or extreme values. Now, pay attention here. The minimum and maximum of a function on an interval are also called the absolute minimum and the absolute maximum. Let's look at the extreme value theorem. The extreme value theorem has two parts. First, if you have a function that's continuous, and second, if you have a closed interval, then the function has both a minimum and a maximum on the interval. Please note this is what is called an existence theorem. It tells you E-X-I-S-T-E-N-C. Can't spell this morning. It tells you that it exists, but it doesn't tell you how to find them. Now let's discuss relative extrema. For relative extrema, you have an open interval containing c, on which f of c is a maximum, in which case f of c is a relative maximum. Now, this is useful because sometimes we want to know what happens with the squiggles, and we just want to focus on what is happening close. We're not worried about the absolute max or min on an interval. We'll discuss how to do those later. Similarly, if you have an open interval containing c, where f of c is a minimum, then you have a relative minimum. Let's look at a couple of functions that we know have relative maxes and minimums. This is the absolute value function, and you remember we already know that f prime at 0 does not exist for the absolute value function because f prime when x is less than 0 is equal to -1, and f prime when x is greater than 0 is +1. And because the left derivative and the right derivative don't exist, the derivative of this function doesn't exist. Oh, now let's look at the sine function. We know sine function has a relative maximum at pi over 2 and a relative minimum at 3 pi over 2. We know this from pre-calc. All right, so let's find the first derivative of sine function, and that's cosine of x. All right. Now, what is f prime? Oops. F prime evaluated at pi over 2. Well, what is cosine of pi over 2? That's 0. F prime of 3 pi over 2 is cosine 3 pi over 2. That's also 0.